All right, everybody, this is a pretty challenging problem. This is from Sim 11, page 6. This is on the angle bisector section. And so I'm actually going to go ahead and work this one through because some of you are asking some questions on it. Okay, so we're trying to find this length here, and this is the angle bisector. It's not the altitude. The altitude is different, okay? So we have this little section here, which I'm gonna actually label that little tiny piece. I could call that little tiny piece a Y if I wanted to. Um, and I think I did a slightly different strategy. I'm going to hang on to that idea that I have to think of that as a separate segment. I'm going to end up defining why I think is this entire part over here in a minute. But we do know that since this is a perpendicular, I can get this part here, right? I can get this here. This is going to be a 3, 4, 5 triangle. I can see that based on my Pythagorean theorem, right? Okay. And I know that this is 3, and I've got another right triangle here, okay? So what I'm going to do is I could use the Pythagorean theorem. I've got, this is 3, I've got another leg. So for this one, the square root of 7 squared minus 3 squared, that's going to be the square root of 40, which is going to be 2 root 10, okay? So this segment here is 2 root 10. So I know the whole length. It's actually 4 plus 2 root 10. I'm going to actually go ahead and maybe round that number if I use my calculator. I've been doing some of my calculator calcs all together and using the number from my calculator so I don't have rounding issues. But I think that it's about somewhere around about 10.32. They did ask you to round to the nearest thousandth, so that would carry it out a little bit further. So I'm going to wait. I'm going to keep this in radical form. Okay, so those are two things that I can easily see. Now this is where the tricky part comes, is that in order to get x, I really need to use that angle bisector theorem, okay? So I'm going to look at a different relationship here. Choose a different color. This, I'm going to call this segment here, including this little piece, I'm going to call this y. And then this piece here, right, is going to be 4 plus 2 root 10 minus y, okay? So now I can set up my proportion here, okay? I can say that 5 is to y as 7 is to the quantity 4 plus 2 root 10 minus y. Okay, it looks really long. Okay, I'm going to use a calculator eventually to figure out what that amount is. Okay, and so what am I going to get? I'm going to get 7y is equal to, here I'm going to break out my 4 plus my 2 root 10, and I'm going to carry some decimals out since I don't want to have too much rounding. Okay, it's going to equal so we're going to say 5 times, this is 10.32, let's carry it out to the 5, okay, all right, minus 5y, all right, then I'm going to do a little simplifying. I get 12y is equal to, and I'm going to multiply this times 5 in my calculator. I get 51.6, says 2277, so 23, okay? Divide that by 12, and again, I'm actually in my calculator, I'm not doing any rounding, so it's giving me kind of a really accurate figure here, that this should be 4.30, it's 189, so 4.302. Someone asked me, how did I get that this little segment here is equal to 0.3, and that's actually how I did it. If I'm going to round out to the nearest thousandth, this is 0.302 because this whole segment y is equal to 4.302, not 4. I'm thinking of 4 in my head there. That's going to be a 2. Okay, all right, so now once I have that, I've got another Pythagorean theorem problem here. I've got x squared plus 0.302 squared is equal to 3 squared. This squared plus that squared is equal to that. So I end up with x squared is equal to 9 minus this squared, and I end up with about 8.909. If I carry that out, take that square root, and x is equal to approximately, I really should be using approximately symbols here because everything is being rounded, okay? And let's see, he wanted me to go to the nearest, I was rounding, this would be 2.9, I've got 8,477, so technically it would be 8.5. And there's your answer, okay? Not an easy problem, but I thought this would help those of you who may have been wrestling with this one a little bit. I'll post this up for you.